Hello everyone. In this video we are going to look at a topic which is very similar to time and work, and that is pipes and cisterns. Pipes and cisterns have a specific terminology. Let us look at that first. So you have something called as a cistern. A cistern is nothing but a tank, or it is also called as a reservoir or a cistern. So there is a tank and you have one or more inlets. So the inlets pour water or some liquid into the tank. So you have inlets. And sometimes there may be a hole in the tank or some another tap that gets out water from the tank. So you have outlets. So this is the basic terminology that is used in pipes and cisterns. Now let us name the inlet. Let it be inlet A and the outlet be B. Right. Now let us look at some of the basic formulas that we are going to use in these topics. So you have, if A fills the tank in X hours, this inlet is pouring some liquid into the tank, and if the tank gets filled up to the brim in X hours, then what will be the amount of tank filled in per hour? Well, again, like time and work, we assume the tank something similar to work. That is, we assume that the full tank as 1. So the fraction of tank that will be filled in per hour will be 1 by X. Now in the same way, if B, the outlet, empties the tank in Y hours, the tank is emptied completely in Y hours, then the tank emptied per hour will be obviously equals to 1 by Y. Now these were individual situations. Now consider that both of these taps or the inlets and outlets are open. Both A and B are open. That means water is filling in or the liquid is filling in and liquid is letting out. Now consider that if you are filling water in the tank and A fills the tank in, let's say, 5 hours, right, and B empties the tank in, let's say, 3 hours. This means that the rate of filling is less than the rate of emptying because it is taking more time to fill in the tank and it is taking less time to empty the tank, which means that if both A and B are open, the tank is going to empty slowly and slowly, right? So in such a situation, when the time taken to fill is more than the time taken to empty, then the tank is emptied. So tank emptied per hour will be equals to the fraction of tank emptied by B minus the fraction of tank by A in 1 hour. So that's one formula right there. Now if in case this is 3 and this is 5, which means that the tank is taking more time to empty than to fill. That is, if you consider the net effect, it means that the tank is getting filled up slowly, although there is some water letting out, but the tank is getting filled up. So if Y is greater than X, then the tank filled per hour will be equal to the fraction of tank filled in per hour, that is 1 by X, minus the fraction of tank emptied per hour, so minus 1 by Y. So these are some small formulas that you have to remember in order to solve questions related to this. Let us solve a question now. So the question is, two pipes A and B fill a tank in 5 hours and 10 hours respectively. If both the pipes are opened simultaneously, in how much time the tank will be full? Well, there are two pipes which are filling in the tank and there is no pipe which is letting water out. So it is given that A fills the tank in 5 hours. That means the tank is completely full in 5 hours if only A is open. So I can calculate the part of the tank filled by A in 1 hour, which is equals to 1 by 5, right? And similarly, the tank filled by B in 1 hour will be equals to 1 by 10. Now, if you have both the pipes open, so we can calculate the tank filled by both of them in 1 hour, and that will be just the addition of these two terms. This will be equals to 1 by 5 plus 1 by 10, and that's 3 by 10. So 3/10 of the tank is filled in 1 hour, right? So what is asked? If both the pipes are open simultaneously, in how much time the tank will be full? So we want the time, that is, let us put it x, when the tank is full. The tank is full when we consider it as 1. So now this is directly proportional. So I can take the ratio and equate. So therefore the value of x is equals to 10 by 3 hours. So in 10 by 3 hours, when both these pipes are open, the tank is going to fill up to the brim. So that's what we have in this video. Solve the questions in the question sets.